Hello and welcome along to this afternoon's session entitled Manufacturing Reinvented with Markforged 3D Printers. Here at Innova Systems we have a bit of history with 3D printers and we're still very excited about our new partnership with Markforged, and hopefully by the end of the session you will be too. My name is Ed Hawkins and over the next 20 minutes or so I'll be looking to educate, entertain and excite you on the Markforged process and their technology. Let's take a look at an agenda. I'll give you a bit of an introduction into Markforged's history. We'll go over the value of composite 3D printing and how it differs from what you might be used to. I'll show you the Markforged range of printers across desktop and industrial, and we'll share a few customer success stories and then summarise the benefits at the end. Markforged was founded in 2013 out of MIT by Greg Mark and David Benheim. Interestingly enough, same place SolidWorks was founded out of all those years ago. In 2014 they released their first printer, the Mark I, showcasing the continuous fibre technology, which we'll find a little bit more about later on. And amazingly, this was actually released at a SolidWorks World in 2014. In 2015 additional fibres were added to the range along with their own base material, Onyx. 2016 saw the introduction of multiple launches with the Mark II and the Onyx, along with the introduction of the industrial series of printers. 2017 was a big year with the launch of metal printing, suspended metal particles that can be printed by fused filament fabrication, washed and then sintered to create usable metal parts. In 2018, the metal range of materials is expanded to include H13 tool steel, Inconel and others. The Markforged difference or methodology is more than just 3D printing. It's about building stronger, usable parts that can be manufactured faster and cheaper than traditional methods. Or simply, design, reinforce, print, and then use. How has this been achieved? Let's take a look at some of the materials and technology that make this possible. Firstly, Markforged have developed their own material for their 3D printers, called Onyx. Onyx is a micro carbon fibre filled nylon that yields accurate parts with a near flawless surface finish. It offers high strength, toughness and chemical resistance when printed alone. If you're used to more traditional 3D printed FDM materials like ABS or PETG, you'll know that invariably the surface finish can be poor, with visible striation lines and limited strength characteristics. This type of 3D printed part has a scope limited to visual prototypes or light use. Onyx is 1.4 times stronger and stiffer than ABS, and the surface finish is honestly amazing. You really do have to take a look at these parts in detail to know that they're from a 3D printer. Taking a stronger base material like Onyx, Markforged then added continuous fibre reinforcement into the mix. A layer of carbon fibre, fiberglass, Kevlar or high strength high temperature fiberglass is laid down on the inside of the part at a rate that you define. Then a lattice structure of Onyx is built up on the inside void. This creates parts that are exceptionally strong and exceptionally light, up to 25 times stronger than ABS and in some cases twice the strength of aluminium. With 4 fibre reinforcement options available, there is a suitable fibre for most applications and price point. Let's take a quick look at a loading test on a carbon fibre reinforced 3D print from a Markforged machine. £22,000 of force, a massive difference over traditional 3D printed parts, and really opens up the conversation again about what can be done and the applications for the technology. Now from a desktop 3D printer we have the capability to print parts with metal strength, durability that are optimised for performance. So what are people printing with Markforged technology? The answer is everything. The scope for what can be produced is huge. I'll take you through a few customer case studies later, but for now, let's take a look at the range of 3D printers available. First up, the desktop range, the Onyx One, Onyx Pro and the Mark II. The Onyx One is a bulletproof desktop 3D printer designed to bring professional-grade reliability, part quality and accuracy to the desktop. Made from a unibody aluminium chassis and precision machined components, it delivers proven reliability over thousands of print hours. The Onyx One prints solely in onyx, Markforged's composite base material. This is a microcarbon fibre filled nylon that yields accurate parts with an impeccable surface finish. Build volume is the same across all of the desktop range at 320mm by 132mm by 154mm. The build plate is removable and attaches kinematically. This makes the removal of the print bed easy and the relocation even easier. Bed levelling is performed manually with a guided user interface and test prints to ensure the print quality. The Onyx Pro builds on the Onyx One and adds the ability to reinforce onyx parts with fiberglass, allowing you to produce production-ready parts with strength characteristics of 10 times stronger than plastic. The flagship product in the desktop range is the Mark II. This adds the ability to reinforce with the complete range of fibres available from Markforged, carbon fibre, fiberglass, Kevlar and high-strength, high-temperature fiberglass. It also brings the additional option of a nylon white base material. All of the desktop printers come with Ethernet, USB and a Wi-Fi enabled. You also get access to Eiger, the cloud software for slicing, file storage and printer fleet management. And they also include an out-of-plastic detection system to ensure that your print's always complete. Onto the industrial range. Meet the X3, X5 and X7. The industrial range sees an increase in build volume at 330mm by 270mm by 200mm and adds in adaptive bed levelling technology. Because the first layer of printing is the most critical, the industrial range includes a laser which scans the bed before every print. It will instruct the user to adjust the bed if necessary and can also make minute Z-axis adjustments as it's printing the first layer to ensure a consistently adhered first layer. The X3 can print in Onyx, Onyx FR and Onyx ESD. Onyx FR is a flame retardant version of Onyx designed for use in applications where parts must be non-flammable. Onyx ESD is a stronger and stiffer version of Onyx for industrial applications. It's precision engineered to possess an extremely tight range of surface resistance, meeting ESD safe requirements of the most stringent manufacturers. Each piece of hardware in the filament extrusion system, from the nozzles to the extruder hobs, is optimized to resist wear from the microcarbon fibre filled nylon filaments and maintain print quality over thousands of hours. The X3 can also achieve a resolution of 50 microns minimum and is adjustable up to 200 microns. The X5 has a third generation fibre reinforcement system that enables you to lay down continuous fibre into the parts. Markforged composite printers are capable of printing continuous fiberglass reinforced parts, and with out of material sensors you can ensure that you're always printing. And finally we have the X7. The X7 can print in all the available base materials, Onyx, Onyx ESD, Onyx FR and nylon white, along with being able to reinforce with the complete range of fibres. The X7 also sees the introduction of turbo print technology that allows you to print up to 4 times faster. Turbo print is ideal for users who need parts immediately and can sacrifice a little bit of the surface finish. It also includes the ability to perform in-process laser inspection. A laser on the print head scans the part for dimensional accuracy, making sure that parts can meet exacting tolerances. Building on this, the X7 is also compatible with Markforged Blacksmith, an automated quality control software. As you slice the part with Eiger, it creates an integrated scan toolpath of the part. The X7 scans the part while printing and creates a point cloud of dimensional data of the printed part. Blacksmith then compares the point cloud measured during printing to the design files, generating a detailed error field for the part and overlays it over the initial STL. This technology allows you to set tolerance limits, compare different prints of the same part, and browse a centralized scan library of print quality data. Looking at the matrix of all the printers against each other gives us a good summary of each of their capabilities. If you would like to see any of the machines in more detail, just get in contact with us and we'll happily show you the printers we have in our office. I mentioned Eiger when talking about the X7. This is the cloud-based software included with every Markforged printer. Eiger is a slicing software, file storage and printer fleet manager. Powerful and easy to use, you simply upload your CAD models, specify the material, the printer you are using and any reinforcement material you want to use. Eiger will do the rest. For parts where strength is paramount, you can control the layers in which fibre is inserted along with the style, concentric, isotropic or full fill. Estimated print time is adjusted on the fly so you can see what impact your choices have on print time. Cost is also shown so you can see exactly how much your part is going to cost based on the material used. Another great advantage of Eiger is that your prints can be stopped. For example, to place inserts or other types of fixings. Because of the kinematic removable bed, this process is easy and safe, as it can be done away from the printer. Prints can also be monitored from Eiger, and as it's cloud-based, this can be from anywhere. Eiger is free to use, so if you're interested in seeing how much your parts will cost to produce on a Markforged printer, or just to find out more about the software, please take a look at eiger.io. Now let's take a look at a few customer stories to see how Markforged technology has helped reinvent manufacturing.
At Caldwell, we make components that go into windows and doors that are sold around the world. We've used the Markforged printers to make everything from prototype all the way through low volume production pieces, tools, and fixtures to aid in manufacturing for assembly and/or test and measurement.
In the past, an engineer would need a part made and I'd have to estimate how long it would take to machine that part. Some of those parts could have 40 hours of machining in them. Today, with the Markforged printers, an engineer will give me a drawing and the first thing that comes to my mind is I want to use the printers.
This fixture to machine traditionally would probably cost 5 times as much and take 2 weeks to manufacture. I printed it in a day and they were able to use it that same day.
This is a production assembly. This is a prototype assembly using both composite and metal 3 printers. This assembly allows you to tilt your windows in for cleaning. Having the ability to 3D print our own metal components has really improved our development process.
The similarities between what we'll print in stainless steel and what we would cast in stainless steel is just incredible. That's something we can get in 2 days in our own lab. The hardware we manufacture is what holds the window together structurally, and if that were to fail, it can mean a severe damage to a building and major disruption for someone's life. The strength of the 3D printed parts that we get off the Markforged machines allow us to put those parts through the same set of conditions that we would test a production piece. They're real parts that have actual strength.
In this highly competitive world, you need every advantage you can get to produce the parts, do your job, have a leg up on your competition in every single part of the business possible. And 3D printing is huge to help us do that.
Cadwell managed to cut their new product development time down from 6 months to 6 weeks, and also reduce their part cost over the machine variants by 10 times. I think the great thing about this is that now it's part of their culture. Not only are they using 3D printed parts for development, but they're also using them for production. Let's have a look at one more, Lean Machine.
One of the big challenges we had with the bending cell was to basically design and integrate everything in a really timely fashion. We were able to actually do it in about 6 months, and that would not have been possible without the additive. We found Markforged by researching for the best printers out there for commercial and industrial quality printing.
One of the parts we make at Lean Machine is an aluminum wire clip like this. The tooling in general, what we used to use was big heavy steel tooling like this to put in our press brake. So one thing we found we could do with printing was actually print these tools instead. The big thing that we saw with Markforged was it took a big step from a hobby printer to something that you can actually make parts out of. And we saw a few sample parts, and then we kind of jumped in with it and haven't looked back. So the first step is that you load the blanks into the trays, which hold 200 parts each. After that, the robot picks the parts out of that tray using an array system and then takes it into the press brake to bend them one at a time. Because of the 3D printing, you have complete control over the profile of your bend. The Onyx is actually very good for friction, and it doesn't leave any marring on the part at all. So we have a much nicer part with the printed tooling, and it's easier and cheaper to make the tool, so it's kind of a win-win.
With the continuous fiber, you make a printed part that not only could compete with aluminum parts, but in many cases actually be a better part. So one of the biggest real gains that we found with the 3D printer is that if we want to get parts made, we don't have to go and schedule them out in the machine shop. We don't have to order tools. We don't have to make drawings. We can skip all of that, and we can just get the parts made on the printer. We come in the next day, the parts are ready, we can start testing with them, and we don't have to go and check that they're right. And being able to have every single feature on a printed part coming out within 2 or 3 thou with Z accuracies of less than 1 thou. I mean, the accuracy stuff is huge.
As soon as we heard about metal printing, it's the next level, so we started looking into it. We're excited about it because, I mean, if we can make some tools work really well out of plastic, it kind of blows your mind what we could probably do out of steel.
For the grippers, they'll just look really awesome on there. The metal printed parts look nicer than most machine parts. We just keep bending thousands of parts, and the tools are not wearing. They're just bending perfect parts. It's like, okay, these guys can pretty much do anything.
That's pretty amazing to see the strength possible on Markforged parts. Seeing them used as a bending tool for sheet metal parts really gives me the confidence that these parts are as strong and durable as Markforged say. Lean Machine have now substantially reduced their reliance on CNC parts and their CNC machines, freeing up time and saving money. Both of these companies are seeing advantages in production by improving speed, reducing downtime, and getting greater yields from their investment. What does this mean for manufacturing in the short to medium term? A lot of possible change across inventory, production costs, manufacturing, logistics, new product development, and demand planning. Generally, your inventory will be physical due to wanting to keep lead times as low as possible for your customers. Production cost is high due to material cost and manufacturing methods. Manufacturing might be done offshore, meaning that logistics are global and often slow. New product development can also be slow because of the constraints on the above. Demand planning can be difficult and slow because of unpredictability. Adopting additive manufacturing as a process can allow your historically physical inventory to become digital. Simply print a part when you need it. Production costs become a lot lower. Customers of Markforged are seeing massive reduction in part costs. Manufacturing moves from being global to being on your desktop. Logistics then reduce. With cloud-based printing, you can send your parts to print in the facility where they are needed. New product development cycles reduce dramatically as you are not constrained by more traditional manufacturing processes. Demand planning can be much more predictable. You are able to print a fully functional part in less than a day. The benefits go beyond manufacturing line efficiency and change the way Markforged customers do business. Lowering production costs can improve the ability to compete. Machinist talent can focus on higher value jobs, should yield greater profit margins, allow you to get to market faster by decreasing product development cycle times, increase the agility of your manufacturing operations by changing lines over faster, reduce money on physical inventory by transitioning to a digital inventory model. It's an exciting time for us at Innova, and we are pleased to be offering Markforged technology to all of you. If you'd like to see the printers up close and personal, please get in contact with your account manager who can arrange a visit. We can also provide some sample parts for you if you want to test them for your own applications. Finally, I just wanted to say a big thank you for watching. I hope you've enjoyed the session.